Yes, so we're talking today about the Federal Information Processing Standards. Um, so yeah, Yash and myself, we're on the same team. We've been at Red Hat for quite a while, a combined 17 years of experience building and maintaining CI/CD pipelines, some microservices, some tools. Uh, so we also, maybe you can see the sticker on my laptop here. It says Conflux. So that's a new build and release pipelines at Red Hat. Uh, and so our team works and we create new checks as needed that run during both the build and the release pipelines. Some of these checks are a bit eclectic, so like they're different needs. So one month we'll or we'll have to implement a check that checks the catalog image. And the next month, we'll have to implement a check that scans for FIPS compliance. So we want to talk about FIPS. We want to talk about our experience implementing a new check in our build and release pipelines. So we'll talk about what is FIPS. FIPS 140 FIPS are Federal Information Processing Standards. FIPS 140 is the particular standard that we'll be talking about. Some terms, the process of getting your container image validated for FIPS, and then I'll hand over to Yash. He'll talk about some open source tools that we surveyed for writing this new check. We settled on one called check-payload, and Yash will also share some of the best practices and strategies for CI/CD pipelines out of our own experience implementing. We were brand new, basically, pretty much brand new to what FIPS is and the tooling required to check it. So first, what is FIPS, or what are FIPS? Federal Information Processing Standards. So this is a program run by NIST, and they publish a series of documents. So you can see on the screen there. I just went right to their website. Those are the most current documents. So actually, if you've been to some other lectures here today, they've discussed some of the ones at the top there for quantum crypto standards, 205, 4, and 3. But we're going to be concentrating on FIPS 140 standards. So these standards are mandated for federal agencies in the U.S. government. So if you're a contractor for the federal government or a partner, you will need to adhere to the FIPS 140 standards.
But also FedRAMP M or FedRAMP H.
Absolutely, yeah. Third party, yeah, exactly. Private sector, especially like finance and healthcare industries, also use these standards, particularly for the HIPAA or in healthcare, or PCI DSS, the credit card network industry. So these standards, FIPS 140 anyway, and many of these other documents sort of are a framework for secure technology and cybersecurity practices, if you haven't heard of them before. They're also not just U.S. based. I mean, FIPS in particular but they also refer to standards by the ISO, drafted by the ISO, and the IEC, so that's the International Organization for Standardization, and the International Electrotechnical Commission. So these are, FIPS proper is U.S. mandated by the federal government, but also referred to internationally as well. So as I stated, we're going to be talking about, we were tasked to check FIPS 140 requirements. So that's security requirements for cryptographic modules. All right, so there's two standards out right now, FIPS 140-2. It's been superseded by FIPS 140-3. And those certifications for FIPS 140-2 are still good for another year until September 21st next year. What is meant by a cryptographic module? So it could be, you could get something certified as a cryptographic module, whether it's firmware hardware like a firewall, a router, a switch, or software. And in our case, since we're talking about building containers, we're concerned with software modules. As an example, I put down there, you can see these are actually packages on my own laptop here, or a container which I was running. OpenSSL, FIPS provider, that's a RPM package basically, or Network Security Services 3, and I just threw in a screenshot there. So you just do RPM-QI. It's just a module. We're talking about a package. Now NIST also runs this program. It co-runs it with the Canadian Center for Cybersecurity. So again, it's not just U.S., it's international. So the labs are accredited, and you get you submit your modules with these laboratories in this cryptographic module validation program. Another acronym. This won't be on the quiz at the end. Maybe the next one will, but the CMVP anyway is a program that's run by NIST and the CCCS, and you, as a vendor, it's like Red Hat or whatever your company, you will submit your module to an accredited testing lab, CSTL, Cryptographic and Security Testing Lab. You'll read in their literature. So, and also the diagram here is right from, actually NIST has great documents and a website. You can find all kinds of information. This is from one of their guides. Okay, so this is the flow of submitting one of your modules to get accredited and to get FIPS certified or FIPS validated. So the accredited lab, you submit it to the accredited lab, you pay money, there's a contract, you sign a contract, do all kinds of paperwork, I'm sure, and they will test it in their certified laboratory. Any problems, you go back and forth with them. Then they will prepare a report. They will submit it to the CMVP, and at that point they may go through it and approve it, or if there's anything that they need to discuss or anything that they think needs to be fixed or retested, they will go back and forth with the testing lab. So finally, when you're approved, you get a certificate and you're listed on their website. You know what? I'm not gonna visit the website just in case there's a problem with the link. But there's links in here where, when we share the presentation, you can go right onto their website and look at certified modules. So if you're a purchaser for software and you want to go make sure that the company that your vendor is indeed certified, you can go right onto the NIST website for that. All right, some terms here. FIPS validated. Okay, this means that your software module has gone through the testing program, through a testing lab, submitted, and CMVP has issued a certificate. It's the only official term. And then there's a couple phases that your module could be in before it's validated, and that could be implementation under test and modules in process. So implementation under test is the term they use for when your module is still being tested by the accredited laboratory. Modules in process means it's been submitted by the lab to the CMVP and they're reviewing it. So you could tell your customers, yeah, we've submitted it, it's in under test, or it's in process. And the links there that I put in, if anyone's interested, is you can also search by vendor and check and see if they're listed there. Although these two phases are optional, a vendor may not want, for some reason, to be listed there. But the final validation certificate, I think everybody is listed there. So another set of terms, designed for FIPS, or FIPS compliant, or FIPS compatible. So what does that mean? It means that your module or your product that calls this module is designed to rely on a validated module that's been through the program. Or it's in process. If it's not validated, it's in process or under test. So those are maybe more marketing type terms. It could also mean that your product will run in a FIPS-enabled environment. So that leads me to the next set of terms, FIPS enabled or FIPS mode. So let's say you're installing a Kubernetes cluster, or like OpenShift, or even RHEL, or some just a single server, and you put it into FIPS mode. That means that it's only going to use FIPS validated algorithms and issue all its certificates. It's done all at the beginning. So your software, whether it's a container image or something else, if you're going to try to run it on a FIPS validated or FIPS enabled mode rather, it could, if it's not designed correctly and tries to call an unapproved algorithm, it might crash. So there might be situations like that. So that's a FIPS enabled or designed for FIPS system would still survive and run in a FIPS environment, or it's actually going to use the validated modules. Okay, so let's pivot to Yash. He's going to talk about, so we're a part of a team that's written a new check for validating container images that have been built to be FIPS compliant.
Thank you, Nate. So Nate here explained us all the FIPS related terms and abbreviations, but when you're building a container, what does it actually mean to make sure that it's going to run on a FIPS enabled environment, right? Now there are a bunch of open source tools available that you can use to verify before shipping your container that it would indeed work on a FIPS enabled environment. Each of those tools are use a different approach at verifying FIPS compliance, and we'll dive into one of those. But here's what we found. So check-payload is one such tool that gives you static scanning capabilities, and it essentially takes a proactive approach by scanning the binaries in your containers and validates that your build configurations and crypto modules are up to FIPS standards. Then there are pre-validated images by companies like ChainGuard and Docker, and you could use those as base images for your container. This approach just gives you a good foundation and makes your FIPS validation check more likely to succeed, essentially. And then there's also SpectroCloud's FIPS Validate, which allows you to scan an entire live Kubernetes cluster with all your deployed images and endpoints, service endpoints. We have integrated check-payload in our pipeline, and so we're going to give you some more information about how and what check-payload does. Again, it's an open source tool. It scans your ELF binaries for, I know most of you are already aware of what those are, but if not, then there's a standard blueprint for programs on Linux systems to put in simple terms. Like, it's much more, there's much more to it, but yeah. So if you see the image on your right, that's the architecture of the tool. It takes 4 primary scan targets. It gives it to a scanner, which runs through your directory tree, extracts all the paths for the executables, and then passes on to the validation engine to validate, to make sure that it meets the FIPS standards, and then prints out the results. First one, scan payload. Now that's for an OpenShift release payload. It's very specific to OpenShift, so we wouldn't dive much into it. But there are other targets that it can take that are more applicable to everyone in the community. One, scan image. Scan image is capable of scanning a container image or an operator payload, a Kubernetes operator. So operators, I like to think of them, for those who aren't aware, I like to think of them as a robot that can help you install, manage, and sometimes maybe even fix your application on a Kubernetes cluster. Again, I'm trying to put it in very simple terms. But yeah, it's, again, in essence, a container image, but it points to other container images inside it. So that's an operator. But scan image command can essentially uses podman to mount the image on your machine. And then, again, it walks the directory tree, emits the paths for executables to the validation engine. Scan local is something similar to scan image, but it allows you to scan a locally unpacked image on your machine. it is especially useful for shared CI/CD systems where you do not want to give root permissions to Podman to mount the image. And so that's something actually we have used. And then there's also scan node, which allows you to scan the entire root file system of a RHEL or a CoreOS node. And yeah, it verifies the compliance for that. This is an example of a check payload scan local command. As you can see, it just goes through the image and just spits out a result that you can consume in a CSV format or JSON, or supports multiple formats. But yeah. So what does the validation and sorry, please go ahead.
So it's scanning for anything that's executable that it finds?
Yeah. Especially
How does it know that something is executable? What's the metric?
yeah, so the question is that does it scan all executables, or what's the metric? So it looks for standard paths for executables and then passes on to the validation, and it has a list and just goes through them and makes sure that these places are there.
By path.
Yeah, by path. Yeah. So yeah, please go ahead.
One of the debug flags, you can actually see all the paths that it scans, whether it's successful or not. It'll just emit them, they say. So.
Yep. Thanks, Nate. All right. So yeah, please go ahead.
Does FIPS committee dictate which paths, or is this up to the vendor to volunteer and state on your own?
So the question is, does the FIPS committee dictate which paths, or it's up to the vendor? So I think in this case,
It's not according to the FIPS
Yeah.
standard.
yeah.
It's any executable is supposed. They're going to make sure that by examining the ELF metadata that it's been built correctly. So it's going to call the correct library for crypto library, basically. So
Yeah. Basically calling a FIPS validated library and not using its own, statically linked one, and not bringing its own crypto libraries. So that's what the validation essentially does. We're just getting into it. So there's a universal check that happens for all scans, which is it verifies the presence of OpenSSL library in standard system paths, and it also looks for presence of FIPS symbols to. But this is like this happens in all scans. Then it scans Go-based and non-Go-based ELF binaries separately. There's a challenge specific to Golang binaries. We'll get to it in a second. But for non-Go-based ELF binaries, it verifies that those binaries are dynamically linked and not statically linked. So like, again, as we just talked about, like they're not bringing their own own crypto libraries into the application. So this is to maintain like a chain of trust. I like to think of the difference between dynamic and static linking is that imagine you have an apartment building with all the apartments having its own private set of books that are not shared among other apartments. That's what I refer to as static linking, while dynamic linking is you have a shared library across the apartment complex and everyone has access to them, to put it simply. This is to maintain the chain of trust that, your application is using the FIPS validated OpenSSL library provided by the OS. And then for Golang binaries, it presents a unique challenge for FIPS compliance because the language's default behavior is to bring in its own native cryptographic implementations which are statically linked, right? I do have to mention this, that beginning Go 1.24, the Golang's native binaries can operate in a default FIPS mode. Their module is still in progress. It hasn't been FIPS validated yet, but yeah, you can find it in this link, which links to Go's official website and gives you all the information about what happens starting Go 1.24. But yeah, to address this, check payload enforces a specific build pattern known as the boring crypto or the Go toolset methodology. What it essentially does is performs a bunch of checks. It validates the Golang version and the compilation metadata to make sure that you're using a FIPS-capable Go toolchains, validates that CGO was enabled while you were building, and also looks for the presence of the CGO init function, which is, again, a low-level confirmation that CGO was indeed used during the build. Again, the same standard check of making sure the binary is dynamically linked, So static linking essentially, prevents that runtime OpenSSL integration, and then it also checks for any conflicting tags being present in your build, like no OpenSSL or things like that, which could interfere with running on a FIPS enabled environment. So what are some of the best practices that you could follow while integrating FIPS scanners in your pipeline? Is consider shifting left. Run these checks immediately after your build to make sure you get a quicker feedback. You can fix things quickly before and prevent any last-minute delays in your release or pipeline. And then we recommend using FIPS-ready base images, as I mentioned earlier, that it just gives you like a good base for building your application on. Now, there's a small nuance here that a FIPS validated base image, let's say you're using a Red Hat UBI or ChainGuard, the certificate is issued to Red Hat or ChainGuard and not to you. So if you're using it in your container, you can claim that your container leverages a FIPS validated base image, or it's FIPS compliant, or it runs on FIPS enabled environment, but you cannot say that your container is FIPS validated because the certificate belongs to Red Hat and not to you. But it's always good to clear it up with legal before using those. And then one important thing is you should complement and not replace vulnerability scanners. It is important to understand that FIPS scanners do not scan for CVEs. They're strictly checking for FIPS compliance and nothing else. I mean, at least check-payload doesn't, or the ones that we've come across. So yeah, here's one way to do it. We're not saying it's the only way to do it or it's the best way to do it, but this is how we do it. We use a step action, a Tekton task essentially in our build pipeline, which is again an open source pipeline Conflux, to scan these container images before shipping them. As you can see, this is a screenshot from our pipeline. We run it alongside other scans immediately after building the image. And this is a snippet from that step action I was talking about. Again, you can see we use Umochi to unpack the image locally. Now, this is calling back on to make sure that commands like podman mount often require root permissions. I promise I'm not trying to besmirch the good name of podman. It's just, I know they're here giving talks somewhere, so yeah, nothing against them. But yeah, we unpack it using Umochi because we have a shared CI/CD pipeline, and then scan it using check-payload. And the results are then gated using Conforma, which is yet another tool that leverages the open policy agent for policy validation. And then eventually, if everything's green, you just go ahead and yeah, cross your fingers that it'll work. But yeah, to summarize some of the key points from this presentation, I know we've thrown a lot of abbreviations at you, but FIPS compliance is crucial for federal agencies, contractors, partners, also in other industries like healthcare and finance, like Nate mentioned earlier. FIPS 143 supersedes FIPS 142, and it ensures your cryptographic module integrity. FIPS validated is the only official term in the industry. Everything else is kind of skirting around it. Open source tools are available for validating FIPS compliance, and check-payload is one such tool. Again, it's open source, so if you need any enhancements or anything, please feel free to contribute. The links are there at the end of the presentation, so after you have access to the presentation, you can go ahead. And then, yeah, importantly, integrate FIPS scanning early in the CI/CD pipelines. So again, a good practice here. We're ready for any question answers and discussions. So even after the talk, if you have any questions, here are our email addresses that you can always reach out to us on. If you don't know the answer to it, we promise we'll put you in touch with the people who do know and help you out. So yeah, any questions?
Thanks. So thank you. Actually, it's interesting because it kind of relates to the process that I was talking about earlier. So when exactly do you interject this type of test? Like, would you say this is the Red Hat build pipeline? And like, can you describe a little bit of the workflow? What comes in and where does it go?
Yeah. Oh, sorry. Okay. So the question was that where do you exactly integrate this check? Is it in the Red Hat build pipeline? And what comes in, where does it go? So great question. It is indeed the build pipeline. We run this check immediately after the image is built. And if it fails, if the check fails, the Conforma policy validation holds it right there, and you wouldn't be even allowed to, trigger a release for that. So yeah, early feedback. The image is taken as the input, as I showed in the snippet. It just unpacks the image, and then we scan the image there and provide the results back to the team that's trying to ship their container.
To clarify that, so the input source. It's like every operator, every single thing that tries to go into, let's say, a new OpenShift release, every operator has to go through this.
Yeah.
And so also, what's the process? What happens with this when it fails? Who knows about it, and how do they get it fixed?
Yeah. The question was like, what's the process? Who knows about it? How do they get it fixed? So every product team or whoever's building the container has access to the pipeline. The moment it fails, they get a notification. They see they see that their pipeline has failed. They see the logs as well as to which images specifically failed. The input is a container image that goes in, and we have labels in our system that if you claim that your product supports FIPS compliance, the task will look at it from that perspective and run that scan, run that check payload scan. But if you're not claiming FIPS compliance, the task is smart enough to identify that and just let you through. So that's how it goes. Nate, do you wanna add something?
I don't want to. We won't go into if folks aren't familiar with what operators are. But we're checking the operator bundle metadata and looking at all the related images listed in there, and those are the individual images that get scanned. So that's a little bit more detail.
Yeah, thanks. Thank you.
Anything else? Anybody else? Yes, sir. Throw him the mic.
I know that the FIPS 140-3 allows for PQC, but it's really weird because it says allows for. How is that impacting a lot of what's going on right now? Because it's like things could end up being 140-3 compliant, but then end up not being allowed because then they're not PQC compliant.
All right. So the question is, FIPS 140-3 mentions PQC protocols, but does it require it? I do not know. We could, I don't know if we want to. You could go right to the standards. It's really, I wonder if, I wish I had my mouse. Will this do the right thing if I just click? Ugh. Okay. All right. So the website's really cool. This you can download the actual document here. They have related documents and standards. And what I would do to answer that, I would click on the link to download the document, look inside, and it would probably refer to another FIPS standard or another document like from the ISO or something like that. When you click on and you look at somebody's certificate for a validated module, part of that reporting that it shows will show all the protocols that particular module was tested and validated for. So, or algorithms rather. Anyway, I hope that answers your question. Okay.
if I may add to it, like the check payload in its current state, I don't think it handles the PQC validation for FIPS. So yeah, we're not checking for that at the moment. So, but it's a good question.
I was going to suggest there's going to be a talk at about 4 o'clock exactly on the topic of PQC, which will cover FIPS algorithms. So reserve your question until then.
today. It mentions it. That's cool. We thought we were all alone, but there's a lot of other talks touching on this subject.
Any other questions?
Thank you very much for listening to us.
Thank you.